AP Chemistry. This is the fourth and final problem of the day 13-14 assignment. It's Unit 2, Lessons 4 and 5. Alright, so what we're going to do is go ahead and start this. I've already done the molar mass conversions because we've done these already. So 44.01 for carbon dioxide, 18.02 for water. This is some form of sugar, sucrose or glucose, C6H12O6, so calculate it the same way we've been doing. We did this one in class at one point also, 180.18 grams that is. That's written right there. And then oxygen, of course, is 32. Okay, so we're going to continue on. How many moles of CO2 are needed to produce 5 moles of sugar? I'm just going to call it sugar. There's a couple of different types of sugar that have the same chemical formula. We'll talk about that at another time. All right, so here's moles of CO2 is what we're looking for, and this is what we're given to start with. Okay, and we start with this. All right, it's moles to moles. I think by now you know that's just, know by now that's just going to be a single conversion. So moles of sugar and moles of CO2. All right, this reaction, by the way, might look familiar to you from biology. This is the photosynthesis reaction. This is what plants do. They take in carbon dioxide from the atmosphere. You water them. You also have to add sunlight, and they produce some sort of a starch or sugar and oxygen. So that's a reaction from biology. All right, so we have a single conversion going from here to here. So the relation is 1 mole of sugar equals 6 moles of CO2. So let's go ahead and write that down here. Okay, there's your two conversion factors. I'll screen a little bit there. Let me move back up here. But you know what I did. I took the equivalency, which was in the equation up there, and converted it into 2 conversion factors. So let's see if we can get this a little bit higher like that. Okay, so which one of these two goes in that box right there? It's a single box, moles to moles. And of course it's going to be this one. Moles of sugar on the bottom to cancel there. Okay. And moles of sugar cancels. Those are the units in your answer. 5 times 6 divided by 1 is 30. And that's the answer to that. Okay. All right. Okay, problem B is a bold-faced problem, so that's for you to do. The answer I have is 3.07 grams of CO2 for your final answer. Okay, again, what I want to see, though, is the setup of that. Okay, it's a grams to grams, 3-step problem. So go ahead and do that one. All right, next is how many moles of H2O are required to produce 4.83 grams of O2? So we come up here, 4.83 grams of O2. Here's O2, here's grams, 4.83. Okay, and how many moles of H2O? So here's H2O, here's the moles row. So that's what we're trying to find out. How many moles of H2O? All right, so 2-step problem. 4.83 molar mass of oxygen gets you into moles of oxygen, and then you move across 6 moles to 6 moles. That makes it easier. You just move over to this question mark. So it's a 2-step problem. Let's go ahead and set that up down here. So our unknown is moles of H2O. What we know is 4.83 grams of H2O. Grams of O2, excuse me. And over here is, okay, and that's 2 conversions. These problems are a little bit tedious and long, but if you do them methodically and you start to get the pattern, they start to kind of solve themselves for you. Okay, so there's our setup. So our first one we said was going to be grams, molar mass. Molar mass is our first conversion to get into moles. So I'll write that down here since we can't see the organizer up there. Sometimes I'm a little loose with putting the zeros there, but you know that they're there, and you know you have to put them in and then put the final answer for significant figures. Okay, there we go. There's our two conversion factors made from the molar mass conversion. One of them goes in there. Which one is it? You need grams of O2 to cancel out, so you need grams of O2 on the bottom here. Grams O2 cancels grams of O2. Now we're sitting in the moles of O2 box right here. Right there, moles of O2. And now it's a simple 6H2O equals 6O2. That's an easy one. So we're going to go ahead and write that. I'll go ahead and write that out. Yeah, let's do it. You can't see up there. Okay, two conversions. Which one goes there? Need moles of O2 to cancel out and moles of H2O to appear on the top there, so it's going to be this one. Even though it's tempting, don't cancel the sixes right now. Again, you want to focus on the units of measure, okay? Don't even worry about numbers at this point. All right, so moles of O2, moles of O2. So everything is canceled out except the units we want in our final answer, moles of H2O. So 4.83 times 1 times 6 divided by 32 divided by 6. And that's going to give us 0.15. I'm just going to go to two places. Well, we can go to 3. So it's 0.151. Sometimes I'm doing significant figures, sometimes not. As long as you understand the concept. Multiplications, divisions, it's always whatever the sig figs of the least of these numbers over here. That's 4.83. You do not count these. These are standards. They're saying 1 mole is exactly 1 mole is how many grams. In this case, it does happen to be exactly 32 grams. At least 4 significant figures it is. But whenever you have these, they do not limit your significant figures. Okay, so there's our answer right there for C. Okay, so we move on to problem D. It's how many moles of O2, so that's what you're looking for, that's your question mark, are produced when 1.52 grams of C6H12O6 are produced. So both of these are on the product side, so it's just asking, you know, if you get how many moles do you get when this much is produced, so they're both on the product side. So moles of O2 is what we're trying to find. So right here, moles of O2, and they want to know when 1.52 grams. So the fact they're both on the same side of the arrow, that's okay. 1.52 grams of sugar. So we're going to use the molar mass of the sugar, 180.18, to figure out the moles of the sugar, and then the relationship between the moles of the sugar and the moles of the O2 will give us our final answer. All right, so our first conversion is, first equivalency is the molar mass, so we'll go ahead and write that down here. Let's get our equation set up first. And we saw that's going to be two conversions, two boxes. Okay, the first one was the molar mass of the sugar. It's a long chemical formula, relatively speaking. Okay, that was a lot of writing. So down here, draw a little line here. Two conversion factors. Which one goes up here in this first box? And we need grams of the sugar to cancel out, so we need grams of the sugar on the bottom, so it's going to be this one. Grams of sugar cancels. We're now sitting in the moles of sugar box, so that's going to be put us right there. We moved from here, molar mass, to here. Now we have the relationship. There's the equivalency. 1 mole of sugar equals 6 moles of O2. So we're going to go ahead and write out that equivalency and the conversion factors. Okay, there's our two conversions. That one of them goes there. Which is which? Okay, let me draw a line here. It's too many numbers there. Okay, so what do we got? Moles of sugar. So you need moles of sugar on the bottom here. That's going to be this one. You need to end up with moles of O2. So that's on the top. So that's what we're going to put. Okay, so moles of sugar cancels with moles of sugar. Last man standing is moles of O2. So now we multiply 1.52 times 1 times 6 divided by 180.18 divided by 1. We'll go ahead and do that. And that's going to give us this. We can go to 3 significant figures. So what I get for that is 0.051. I can actually add a 0.6. Actually, I could have gone, that's only 2 significant figures. Again, I'm kind of on and off with that. It's up to you. Whatever, anything close to that I'll take on this. Okay, so there's your answer for that. All right, E, you are going to do on your own. Okay, so there's the answer I have for that. It's asking us for grams of O2, and that's the answer that I have right there. If you disagree on any of my answers, email me or shoot me a... I prefer an email, but you can go through Canvas either way, and I'll respond to you if you have any questions. Okay, all right, going on to the last one. And it's how many moles of H2O. So moles of H2O is our unknown. We'll just put that down right away. And we're starting with 8 grams of sugar. Okay. So 8 grams of the sugar. There's the grams. That's 8. And we're trying to get to moles of H2O. So here's H2O, and we're in the moles row. So there's the question mark right there. So you're moving up from grams of sugar through the molar mass to get moles of sugar, and then from moles of sugar across to get moles of H2O is what you're looking for. So it's a two-step problem. Okay, so the first one is the molar mass of the sugar. So we're going to write that down here for the last time, thankfully. Although there's much longer chemical formulas for compounds that we will come across. But I do actually try to pick them that they're short so you can write them quickly. Okay, that's the equivalency. That's basically the molar mass conversion up there. Now we're going to do the 2 conversion factors. Okay, there's the 2 conversion factors. Which one of these 2 goes up there? You need grams of sugar to cancel out, so you need grams of sugar on the bottom here, so it's going to be this one. Screen, in case you didn't see all of that, I think you know what it was at this point. Okay, grams of sugar cancels with grams of sugar, so you're now in the moles of sugar box. You're sitting right there. You went from here to here. Now you got to go moles of sugar to moles of water, and there's the equivalency right there written for you. Okay, so there's the moles to moles conversion factors. So one of them goes there. Which one is it? Well, we need moles of sugar to cancel out, so we need moles of sugar on the bottom here. This is the one that does that. Moles of sugar cancels with moles of sugar. Final units are moles of H2O right there. So it's 8 times 1 times 6 divided by 180.18 divided by 1. So that is going to be 0. We can do the 2 significant figures if you're thinking about that. So it's going to be 0.27. You write it up here, be sure it's clear. 0.27. There's your answer right there. Okay, long but very, 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 very important assignment. Okay, this is really getting you into stoichiometry. We're going to move into, this is with grams. We're going to move into other types of stoichiometry next week with solutions and with gases. As long as you understand the principle of how you set up your equivalencies, your conversion factors. I'll have graphic organizers for you to view. Use those as you need them. You kind of want to get away from using them. You're not going to have them on the AP exam, and you want to get to where doing these problems is a little more intuitive, but that only comes with doing a lot of problems. There's no shortcut to it. Some of you it'll come quicker, some of you not as quick, but it'll come if you practice enough. It's just we all have a different number of times we have to practice something to get good at it. And just find out what your number is and do that number, and you'll get good at it. And eventually that number will become lower and lower for you. You'll start to get things quicker.